Welcome everyone to this week 2 special session of the PMRF TA sessions for the NPTEL course Electronic Properties of the Materials Computational Approach. So first a brief introduction of mine. I am Akshay. I am a PhD student PMRF in the Solid State and Structure Chemistry Unit, SSCU of the Indian Institute of Science, IISc Bengaluru, India. And I did my BTech MTech dual degree from Indian Institute of Technology IIT Kanpur in the Department of Material Science and Engineering. I am an NPTEL-PMRF TA for this course, Electronic Properties of the Materials Computational Approach. So usually we are having our this problem solving sessions every Friday from 7 to 9 p.m. But today on Wednesday 30th August we are having an extra session other than the usual sessions on Friday. So in this session in this session what we are going to do is we are going to have a small Python tutorial since Python is being used in this course, and some of you guys may be quite new to this programming language. So just to make you guys more comfortable with this, in this session we are going to go through some basic tutorial on this Python programming and also on the NumPy and matplotlib libraries. And then if time permits, then we will also try to look into some quantum mechanics part as well, quantum tutorial like the Dirac notations and the computation of operators and the eigenvectors and eigenvalues problem, which is a green algebra part but quite useful in quantum mechanics. Alright, so let me just start with this Python programming part. Alright. Okay, let me just now okay. So let me just give you a brief introduction of about Python. So Python is an interpreted high-level programming language. It allows us this is the main benefits why Python is being used in so many. Just 1 minute. Let me just check if recording. Sorry about that. I have to just check the recording. Okay, let's just start again. So let's just start with the introduction to Python, what Python is. So we know that it is an interpreted high-level programming language, and the importance why Python is so popular nowadays, it's because it allows us to express very powerful ideas in a very few lines of code by being very readable. So basically Python is a much simpler programming language compared to let's say C or Fortran, you can say. So because it is very easy to understand and also it is so powerful. That's why Python is quite popular nowadays. A brief a brief history about it. So it is developed by this guy Guido van Rossum in 1990. Sorry if I pronounced the name incorrectly. So this guy basically he developed the Python programming 1990s, and it was named after Monty Python instead of like people think like the Python snake. It is named over, so it is named over Monty Python. And there is interesting it was according to its developer, it was made as a need for a language to bridge C and the shell. So that was the motivation behind this building of Python programming. So from the application point of view, it has quite many applications. Like it has application in web and internet development. It has application in scientific and numerical computing. For that, it has this SciPy and NumPy libraries. They are like quite important for the scientific and numerical computing part. SciPy is this scientific Python programming, NumPy numerical programming. For education purpose, as you can see in this course also, Python programming is being used. And then for some other application also like desktop GUIs, it is also used in this software development and this business applications as well there are. So and then to learn more about Python, you can go to this Python websites, their official website, and you can python.org and learn more about Python. So this is just a brief intro to Python. Now let us just start with our tutorial. So let me just stop sharing here, and alright, let me just start sharing now here. Just one minute. Okay, let me just wait. Let's go here and start sharing. Present now. And go to Python basics and share. Alright, okay, so we are online now. Okay. Right, I guess. Right, I hope you guys can see my screen, and yeah, I guess it is visible. So, let's make this screen possible. I guess this visibility is better now. Okay. Yeah. So okay. Yes, sorry about that. Okay, yeah. Now, okay, let's start with our tutorial. So just check if recording is being done. Okay. So let us start with our Python tutorial. So this is a very short, brief tutorial on Python, and for further learning, I would recommend going through this another tutorial, which is this one. This is the ring. So this ring is provided. Okay, so let me just share this one. Yes, no, it's not. Okay, yeah. So you can go through. Okay, yeah, you can go through this link, and this will show you. So let me just stop sharing again, and let me share again this site. I don't know how. This one. Let me just share. Okay, so first let me just share this link. So yeah, so first so this link is provided in the Chrome notebook, which will be shared, and in this so we are going to do a brief Python tutorial, but other than that, you can also go through this Python notebook as well. The link is provided. So I have taken some of the parts of this tutorial from here, and this link. And there are it has actually more, like it has for scientific Python, SciPy as well, which we are not going to cover in this tutorial. So this also you guys can go through, and so this is I guess a little bit more detailed tutorial, but some of the parts I have taken from here, and they have a collab notebook as well. Alright, so let's just go to our sharing. Share screen again. Python basics and share. Correct. And just check if it is visible. Okay, it's quite visible. Okay, so one can go through this link and that site that I have shown, and maybe they have some more material like on scientific Python, on SciPy library as well, so you can go through that. Now okay, so yeah, So first, as you can see in first shell, there are just two comments, which just explains that okay, go through this, go to that link for further learning. So basically with this this symbol, you can comment, you can give comments in the Python code, and comments are just useful to understand whenever you come back to your code, like whatever you have written. Okay, so then let's start with, so this is a very small amount of understanding the Python version. So there are various versions of Python. Most common is version 2.7 or 2.8 something, and but nowadays there are now the most recent I guess is 3.11, and in this Chrome notebook also the Python version 3.10. And there are certain difference between Python version 1, this 2 and 3. So I would recommend to go through Python version 3 only, and we are doing on Chrome notebook, so most likely you guys will also have the same Python version. But just check it, like which kind of version you have. So there might be some issues whenever you code in Python, and there might be some errors, could be some, like some syntax or something that is not, that might not be your fault. It may be the version that you are using. So those syntax and those functions maybe that you are using, they are not within that version or not compatible with that version. As for example, like in Python version 2 and 3, there is a major change in the print command, as I remember. So nowadays I just use, so it's better to just use the most latest version. So Python 3.10, 3.11, you can. Okay, so let's start with variables. So variables in Python, we can think about like some simple variable like integer, float, string, or boolean variable. Here in Python, you don't need to define, give Python that okay, this is an integer variable or this is a float variable. In this, you just gives the variable, like you define a variable as some 30,000 and b as some 30 point something. So the Python understand itself like okay, so this is an integer, this is a float, and if you provide this a string variable like this, and it understand it's a string. If you provide this true false, then it understand this is a boolean variable. And if we run it, and so here I'm printing the value of this variable a, and then with this I'm printing is, and then I'm printing the type of the function. So this type function, this tells us what is the type of our variable. So our type a is an integer, while b is a float, and the value is 30.0. Then the c, so you can see that if I print variable a and c, they seems to be same, but as we can see, the variable a is of class integer, while the variable c is class of is a string. It's a string variable. And then this d1, this is a boolean variable, as you can see, and its value is true. Alright, let's move on to, okay, now so now we have variable naming. So the variables name in Python, you can start with any letter or underscore, and then we add the letters, and then we can add letters and numbers. For example, like you can have a variable name like var and then 1, or you can start it with an underscore as well, and there will be two different variables. Okay, and let us give it this a shot. Okay, yeah, so this is running properly, and you can see that okay, it is printing the values of stored in this variables, where var1 has value 3 and underscore var1 it has value 4. Now if I try to give it this name like 1var, then you can see that if I run this cell now, then there is some issue, and it is saying that the invalid decimal literal. So this is mainly because I could not start a variable name with a letter. I could start it with a number, I could start it with a letter or with an underscore only. Alright, okay, so now let's, okay, now then there is one more point. So there are some keywords that cannot be the variable names, for example. So they are already have some specific meaning, specific purpose in Python programming, so you cannot use them as variable names. For example, let's say I want to define a variable name by def. Def equals to 10. Now if I run it, then it again gives me an error, and the error is that this is an invalid syntax. Okay, because Python this def is used to, as we will see, it is used to define a function, and so when Python sees it, it thinks like you are doing something wrong. This is a syntax error. You can't assign a value to this keyword def. All right. So let's go. All right. Then we comes to our first type of this data type, which is strings. So in strings, so here we have an example. We have a variable and we have put this string. Now strings we can define is by single quotes or by double quotes. So here hello is divided and both of them works. Then if I print the value hello, then it prints this value, the string value hello. Here you can see, and this type of word, and I'm printing the type of this word variable, which is a string. Then you can also print the length of this string. So if you print the length of string, so it will have all these values like 1, 2, 3, 4, 5. So it has like 5 elements the string has. So the length of this string will come as 5. Here you can see the length is 5. All right, and then they are also mutable as well. So basically, and then the variable is like you can change this variable hello to some h, capital H, and what happens is that you will have some then it will change. It will assign this h string to this variable. So that will happen. That you can do like if you can reassign something else to the variable, then it will forget that it has this value, and now the variable will contain this value h only. Right. Then let's come. Okay. Then let's come to this example. Okay. Let me just check. Just 1 minute. All right. Sorry about that. Okay, yeah, so let's say now we have a string and we want to concatenate, we want to join some strings. So we can do concatenation just by using a plus sum. So if you use a hello plus the space word and we print this, then this new variable will be hello word. And there is one more thing that I have not included here. So let's say I'm writing this a new variable. Let's say well, and I say HW times 2. Okay, I'm doing an HW times 2. Then what do you think could happen in this case? Okay, so what will happen in this is that okay, so what will happen is, so basically if we do a multiplication for the string, so what it does, it doesn't like it's not going to multiply a number to it. What it will do is, if I do multiply 3, then it will just this new string will have the same string twice. So the hello word will be twice, and there is no space was added, because in this string HW it is just up to D only, there is no space afterwards, and then we have just concatenated again that thing. And if I just multiply it by 3 or say 4, that's 4, then what you will see is that it will just like multiplying this thing by 4 times. It is storing the same hello word string 4 times. Okay, it is like multiplying, it's hello word 4 times. Alright, then so now these are some useful methods for string objects. Okay, so let's say the variable s is hello. Now we do an s dot capitalize. So what this does is it capitalizes the first letter of the string. So so if it is hello, then it will become capital H, hello. Then s dot upper. So s dot upper, what this does is it converts a string to uppercase. So it prints a hello. These are okay, yeah, so basically, yeah, so if you do an s dot upper, then it will convert a string to uppercase and prints the capital hello. So all the letters are capital HELLO. Alright, and the next we have is s.rjust. So it just light justify the string or padding with spaces. So you can see that it is right justified. Then you can do an s.center as well, and this number basically just define like this justification. So if I do a 10, then it will just move more towards the right side, as you can compare now. Right, and then s.center, it just center the string. And then we have s.replace. So what s.replace does is it replaces, like if this has a letter L in it, then the L will be replaced by this. Let's just put some Z in this. So what will happen if we have a Z which is not there? So it does nothing basically. So if you do s.replace ZELL, since there is no Z to replace, it does nothing. But if you do an L here, then we have two L's, and you replace this L's with this ELL brackets EL. So it replaces all instances of one substring with another. Or we can do a double L as well. Like let's say you can have double L substring, and you can just, so basically it replaces that substring instance, or all the instances of the substring of that substring with some another substring. And then the last thing that is dot strip. So what does dot strip does is it strips the reading and the trading white spaces. So if I have some white space here in the start and in the end, if I just do a dot strip, then it will just remove both those spaces. Right. Then let's go to our next data type, which is like integers and floats. So in this as well, there are all this kind of tutorial. All these things are given in that tutorial as well. Okay, now let's go to integers and floats. So let's say I am defining an integer I equals to 7, and let's say define some float with stored in variable f as 7.4. So we have integer and a float. So let me just run this first. So we have this. So okay, so here you can see, okay, so we have integers. Let's say I equals 7, say, and if I do a print I comma type I, so I know then it prints a value 7 and class integers, because this is an integer. Then we take this print f comma type of f. Now f is a float. All right, so f is a float, and it prints a value 7.0, and it says, okay, this is a float. Then this is an example of integer addition. So we can do I plus 3 will be 7 plus 3. It will give us a value 10. Okay, so we are getting a value 10. And similarly, if we can do as I minus 4, which is 7 minus 4. This gives a value 3. And we can do similarly, we can do if it is I times 5, it is 7 times 5, it will be 35. Alright, and then okay, now here what happens is that if we do an I divided by 2, we know that 7 divided by 2 will not be an integer, it will be some like 3.5, we know. So that 3.5 we know it's a float. So we can see that it is identifying that over is 3.5, and it is actually float type. Then you can also print, if you take I double star 2, then this is for the exponential. So that is just 7 to the power 2, which is 49, 7 square 49. Then what happens if we have, okay, now I is an integer and f is a float. Now if we do a multiplication of this integer and float, so what we are going to get, what we will see is that if we do an operation with an integer and a float, then our answer will be in float only. For example, it is 7 times 7, which will be 49. So since f is a float, and thus it will, instead of 49 we will get 49.0, and the type as been mentioned, it will be float. Then if we do an I plus f, again it is 7 plus 14. but it will print a 14.0 and will give us a float value. Okay, here you can see it is 14 and class float. Then if you do a I minus f, it will be 0, but it will print a 0.0, and again this will be a class float. Okay, I have given type I minus f, and I divided by, if I do an I divided by f, so it is just 7 divided by 7.0, which is just 1, but the answer will be 1.0 because f is a float. So again I divided by f will again be a float, so this will again be a float. Alright, and okay, and one thing more, you can see that within the print command also, I didn't mention, but I guess you must have observed, is that we can do operations and or within the print function as well, and even within the type function we can actually do this operations. Okay, and then this is also some. Okay, so if we want to increment some our variable, our integer variable by some number, let's say 1 for now, then we can write it as I plus equal 1 instead of writing I equals to I plus 1. So what we will get is just 8. Here value that we have got is 8. Then if we if you want to use write I equals to I minus 1, if you want to subtract our integer by some particular number, then we can write it as I minus equal 1. So that will be equals to I equals to I minus 1, and that will give us, like, we have changed our value I to 8 in this step. In this step we have changed it to I equals to 8, and now in this step we will again comes to 7. Okay, so there we are printing the value 7. And if you want to multiply our integer with some integer number and store it within the integer, so we are basically, what we are doing is that we want to write I equals to I times 2. So that we can do. Okay, so we can change our value of I by multiplying by 2 and then storing it back into I. We are updating the value of I. So that could be by I star equal to, and that will be print, and if we print I, then it will be 14. Okay, so our I value has changed to now 14, from 7 to 14. Okay, and there was one more thing that I didn't do. So if you do a print, so what we can do is we can also actually change the an integer to a float. So that could be done by let me just do it. So here you can see, so what I did was, okay, so we got we have changed our I from here. You can see that we first write I equals to I plus 1 using this. So we got an 8, I equals to 8, then we do an I equals to I minus 1, so 8 minus 1 7, then we do I equals to I into 2, so it's 7 times 2 14. Then what we did is we can change our integer to float as well by using this float function, which is float, and then you put your integer value, and then if we print the value, then we print I comma type I. Then what will we get? We will get a 14.0, and now our integer I, which was storing an integer value 14, now it's storing a float value 14.0. Alright, so let's go to booleans. Okay, boolean data type. So here we are storing this boolean values true and false. So they are these keywords are predefined in Python. So we are storing these values in our variables t and f. Now if I print the type of t, then this will come as a bool, or which means it's a boolean variable which will have a value true or false. Using this, and then we have this logical operations as well. So as we have logical AND operations, so if you remember, if you have logical AND operations, it's like if both the functions are true, or if both are true, then only that will be true. So if we print t and f, and both t and f are, like, t is true and f is false, so what we are going to get will be a false, and that is what AND logical is. Now and say if both are true, okay, let me just, I guess I should or let me just write it like this. Okay, let's do it. Okay, so let's see. Okay, yeah. So, sorry. Now I guess it will be much more clear. Okay, so let's say we have. Okay, I have done some. Okay, yes, I understand. All right. So let's say we have a true and false value, and this is our. So this AND is also a keyword within Python. So this gives a logical AND or represents a logical OR. This exclamation mark equal, since that it is not equals to, so it checks if this is not equals to this, so that will act as a XOR logical operator if we have this boolean values T and F. Okay, because if you remember, and not that just changes this flip the value, so it acts as a logical NOT. So let's just check this thing. Okay, so basically you can see that okay, true and false will give false. So we know that how if you remember the table of AND logical, so true and false will give you a false, and only in true and true will give you a true. So let's just check it if that is true. Okay, so true. Okay, or let's just start with true and false. Okay, so if we have T and F as true and false, then true and false will gives you a false. True or false will gives you a true. True X or false will give you a true, because what XOR logical is, it is true when both of either you have a true false or you have a false true only, but not if you have both the truths are or both the false are, then it will be a false, and not true gives you a false. Alright, and you can just check by if you just change this value, like if I just put all the values as false, if I put all the values as false, then what has happened is false and false will give false, false and false or false will also give false, false X or false that will also be false, and not false that will be a true. Alright, so we can check how complete this logical table from here. But I guess this is clear, like okay, like how this logical operators, this keywords are mainly used, and how this not equals to is done. Then if you want to find what is the integer value of this true and false, like so basically what I'm doing is I'm converting this. We can convert this Boolean variables to integer variables as well. So if I do a int and int T and int F, so we can see that true corresponds to a value of 1 integer, correspond to an integer of value 1, and false correspond to an integer 0. Okay, so like if we convert a boolean variable to an integer, then for true we will get a 1, and for false we will get a 0. Then and also if we check if we convert any integer value to this boolean value, so what we will find is that any non-zero value will give a true boolean boolean variable with value true. So for to check this, like we have a positive integer like this 1000, same like negative integer which is minus 1000, and then we have zero integer which is basically 0. So here you can see that when we have printed, so this 1000, if I change it to bool, so by giving this bool function, I can change the positive integer to a boolean variable. Then the boolean variable value will be true. For a negative integer, so it will be true, but only for a zero integer value, it will be false. Okay, and let us try if can you get a float value. Now one would ask like, okay, can you get a float value for this? So if you have question, just try to, and you can say that okay, I've just did it for integers, but you can check it for float as well. So if you convert this float with this, so that will be a 0, and if you do a false, it will give you a 1.2, and if you do a false, 0.0. So for float also it will give a 1 and 0 value, but 1.0 and 0.0 which will be a float. And you can check for the same again in the same way we can check for 1000 point something, a positive float, then that will be a true value, but only a 0, 0. And even if you take some like negative value, that will also be a true value, and only a 0.0 will give you a false. Alright, 0.0, it understands that will give you a boolean value false. Alright, let's move on. Alright, that's okay. Alright, so let's go to data containers in Python. So they are built-in data containers, lists, tuples, dictionaries, and sets. So first let us go to list. So lists are basically a Python equivalent of an array, but is resizable and can contain elements of different types. Okay, so we can change the size of our list, and it can also contain elements of different types. Okay, instead of a normal array. So for example, let's say I made a list. Okay, you can create a list by using this square brackets. So I created a list of 312. You can create an empty list as well, and in these two ways, either you just put this two square brackets and which is empty, which has nothing in it, so that will also create an empty list, and or you can use this list command, and that will also create an with this parenthesis, and that will also create a empty list. Alright, now if we print this list, LST list, so which doesn't have anything, so we will have it has printed an empty list. Again, we have printed list 2 is also an empty list. Then we printed this X list, and we are printing this index 0. So in Python, the indexing starts from 0. So for this list, the index will be 0, 1, 2. It has 3 variables, and the index starts from 0. So for index 0, we will have 3. For index 1, we will have 1, and for index 2, we will have 2. So when I print xx, xx, and giving index 2, so it prints this list 1, 3, 1, 2, and then this on the 1th index it will be 0. On the second index it will be 0, 1, 2, it will be the value 2, so it is printing a value 2 here. Alright, so indexing starts at 0 in Python, that is important to remember. Then negative indices count from the end of the list. So we can even give a negative index. So if I give a -1, then it will count from the end. So if it is like 312, so it will count from the end, so it will go to this index, this index value, and it will be 2. Okay, so let us print xx -1, that gives you a value 2. Here you can see this is value 2, and if I give a second index -2, so So you can see this value 1. So when I give it -2, so what it does is it goes back to here. It gives this as -1. 2 will have the index -1, and 1 will have the index -2, and then 3 is going to have the index -3. Right. So in this positive direction, you can say 3 will have the index 0, 1 will have the index 1, and 2 is going to have the index 2 here. While if I put -1, then the 2 will have the index -1, 1 will have the index -2, and 3 will have the index -3. Alright, so we can do a negative index count is also possible. Then if we have printed the type of SX and the length. So type is a list, it's a list type, and the length is 3. So because we have it has three values are stored, 3, 1, and 2. All right. Then we need then this list, as we have said, they are mutable. So what mutable means is that the elements of the list can be modified, individual elements can be replaced, and the order of elements can be changed even after the list has been created. Alright, so lists are mutable. So basically what we can do is we can modify these elements of the list. We can individual elements, we can even replace the individual elements, and we can change the order of the elements as well. So for example, let's say there is this method xx.sort. Alright, so what this does is that it will sort the list in the ascending order. So our list was 3, 1, 2, and if we do this, then it will sort it in the ascending order. So I have printed this print ascending order, comma sx, and after doing sx.sort, then what we are getting is that now the xx has sorted out, and it is sorted in ascending order 1, 2, 3. Alright, and if I do an sx.sort reverse equals to 2, so it has this parameter. So basically these are the methods for this data type list, and this is the parameter reverse, and so and they have several parameters. For example, for the sorting method, we have this parameter reverse, and if this reverse is equals to 2, then it will sort the list in the descending order. So here we are seeing that descending order, it will say 1, 2, 3, it will sort descending order 3, 2, 1. Alright. Then list can contain elements of different types. So what I can do is, and they can be modified as well. Okay, so I have like xx equals to 2 at the second index. Okay, so I have an xx which is like 0, 1, 2. So I can call out this xx of 2, and now I can modify it. I can even change it to a string as well. So not even a number, I can change the integer value to with a string value as well. So list can contain different types of elements, and I can modify them as well. So here I have modified this. So here you can see that now if I print it, I will have, instead of 3, 2, 1, I will have 3, 2, and I will have 2, because I have here 0, 1, 2. So second index, which was 1, here 0, 1, 2. Okay, here this 1 has been replaced by this string foo. Okay, so we can change the each of the elements. Changed. Right. And then you can also add a new element to the end of the list by using xx.append. So what happens is, when I did this xx.append, then it appended a value bar at the end of this list. So you can see after this it becomes 3, 2, foo, and then we have a new element bar in the list. Alright, then I can also append for list any a number as okay, yeah. Now this is our list. So this is our empty list, if you remember. So basically we had the empty list, and now we can add some values to it by using this append method. So you can use this list.append 450, and now our list was not empty, it has a value 450. And then our lst2 underscore 2, that was also an empty list that we created by another method, if you remember. We created lst by this square brackets, and lst underscore 2 by this list command. So we can again lst2 lst underscore 2 dot append, I can append and I can put a string there. So my lst, and if I print this now, lst underscore 2, so this has an element with this string value Akshay. All right. Then we have another method, which is the pop. Okay, so with this pop, what happens is that we remove and return the last element of the list. So our access list, at the end, what we have obtained was this 3, 2, foo and bar. So what this pop command will do is it will remove that last element, and also it will return that value. So, and that return value is now being stored here in this variable x. Yeah, so now the x, so what happens is that if we print this x and xs, so what we'll get, it x has the value this bar, all right, bar bar, so that is there. And now our xs list has changed. We have popped out that last element and stored it in x, and now our xs list is just 3, 2 and 4. All right. Then you can also use help to find more about any stuff in the Python. So for example, if I use help list.append, so what it returns me is this, like append is an okay, so sorry, not help on method descriptor. Okay, so it understands that we are asking for a help on a method descriptor. So it goes and tells and gives a description from the from its documentation of Python, and says that this append, it is used to append object to the end of the list. So that is the quite helpful. So whenever you are stuck and you don't understand like what is that thing, or you can, like, for example, I can search anything like this dot pop. So it will tell me what this method does. So I don't remember like what this dot pop does. So it gives, with this help function I can just know, okay, it will tell me like it remove and return item at index. Also, like, there are some other parameter I can even use an index, like if I can even give some index, and generally it is index is equals to -1. So that also it is telling me, okay, it returns an index and default is the last value. So I could have given some parameter here, index equals to something. So that would have similar to like what we have done here, like we have given some parameter equals to it. For example, like in this example where I have done this, let me just alright, so now what we are doing is, now instead of sx.pop, I can give an index equals to -2. There is some error. Alright, yeah, so index not equals to, yeah, you just have to define -2. So now what will happen is that if I have print x.xx, so this was our xx list, alright, and I have put -2, so now it goes to -1, -2. So the default was -1, but if I go to -2, then it will remove this this element foo, which was at index -2, and now it is 3, 2, 1. I could have put in some 0, 1, 2 as well, so you can just put any other value, and this help command is helping me here. So this help command I used, and then I came to know, okay, not only the last index, but which is the default case, but I can actually remove any of the I can remove any element of any index, basically, sorry, from the list, using this pop command, and I just need to provide some more parameter to it. Alright, so that is why this help function is quite helpful, you can say. So let's just move to, I guess, after list. Okay, yeah, slicing list. Okay, yeah, so slicing list. Okay, we are quite behind already. It is already 15 minutes. Okay, now let's come to slicing list. So let's say let's do the command list range 5. So again, we know that with this list command we can create a list. So range, let me just first talk about what is ranges. So range is a built-in function that creates a list of integers. Okay, so list. So range basically is a built-in function within Python which creates a list of integers. And if I do this list function, then it will convert this range 5. Oh, okay, if I just print this just to show you that what is the difference, because the class type is actually different. So to be helpful to use it. Okay, so if I put range 5, then it will just give you a range 5, range from 0 to 5, and I can convert that range into a list. So that will this will give me a list from 0 to 4. So it will exclude the number 5 which I have given in the range function. Okay, so this could be used to create a list of integers. Now okay, so we have printed it, and then now we can do the slicing of it. So slicing means that, okay, so we can let's say we get a slice from index 2 to 4. Okay, so if I give this nums 2 and colon 4, I guess it's called colon, okay, 2 colon 4, then that gives us that will print a 2 comma 3, as we can see here. So what it does is it takes it slice this indexes from index number 2 up to index number 3, from 2 to 3, which is n minus 1. So like it is 4, it will exclude the index number 4. So I will go to 0 1 2, my index number 2 has a value 2, index number 3 has a value 3, and only this 2 I am slicing it out. So I will slice it out from this list, this part, with the help of this nums, this colon 2 comma 4. This helps me to slice out this section from the list, index 2 and index 3, and I get this 2 comma 3 list. Alright. Similarly, we can have this, we can get now what this 2 column which does is it get a slice from index 2 and to the end. Okay, so if I give this 2 column, if I use this one for what this nums 2 column means, that I will go to index 2 and then I will go up to the end. So it will give me a value 2 3 4, and and that is what I have printed here, 2 3 4. Right, then we have nums this colon 2. So if we have 2 columns, so that goes from index 2 to the end of the string of our list, and we have column 2, that means start from the starting index to this index excluding this index. Okay, so what happens if we have providing some index number there, so it will always at the end or at the right side of the column, then it will always exclude that index number. So I will take the up to 0 and 1 only. So I will just take 0th index and the first index. I will not and at that I will stop because of this. Okay, column 2, it means I have to slice this 0 and 1 index only, and thus I will get this 0 1. Okay, if we just provide this column, then that means get a slice of the whole list. So it will just split the whole list from 0 1 2 3 4. Alright, this thing will just get a slice of the whole list. Alright, and then if we can also again provide the negative index as well. So if I do this, then we know that if we have something on the right side, it means starting from the starting index to this index excluding that index. So minus 1 means the last index, so I have to exclude this one, and I will slice out all this list to 0 to 3, and that's what we have done here. Alright, so we have, because of this nums colon minus 1, we will get this 0 1 2 3. Alright, then now we can also assign a new sublist to a slice. So let's say as we know that lists are mutable, so I can even slice, like say I'm taking like nums 2 4, I can even assign this slice to 0 1 2, second and third index is 2 3, and I'm saying that I'm assigning this slice, this sublist, to a new value 8 9 using this slicing method. And now if I think this 2 3 has been replaced with an 8 9 within the list nums. Alright, that is the slicing of list. Alright, and let's come to a for loop. So for loop, it is a looping over elements. So let's say we have a list animals which has this elements cat, dog and monkey, and if we print this type of this animals, then this is basically it is a list, and then we can use a for loop. So what for loop is gonna, I can use like for animal in animals. So like for loop, just take like for some animal. So I can do in the animal I can use like some x as well. Okay, you can take some x as well. So that is the variable that you are saying that okay, in this variable for all the elements in this thing, whatever is written here this is a list. For each of the element for each of this element of list, print that element, and it is printing cat, dog and monkey. And you can just go with animal. So animal is just some variable that I'm using here. Alright, now let's get to list comprehensions. Okay, so this is important and we will use it in one of our tutorials as well. So list comprehensions means shorter syntax when you want to create a new list based on the values of existing list. Alright, so this is this means that we create a shorter syntax for when we want a new list on the basis of the existing. For example, let's say we have our index, we have list is nums 0, 1, 2, 3, 4, and we want a list which is the square of each of these elements. So one thing that we can use is we can use this for loop, as one could do like okay, for x in this nums, for x in for which means e for each element in this integer nums, for to which we are which value we are assigning to this variable x for each loop. What I can write is a squares dot append. Okay, we know that we can append it, and x star star square and then print squares. Okay, so from here by this we can get the list which is the squares of these numbers. From 0, 1, 2, 3, 4 we can get 0, 1, 4, 9, 16. Alright, so we can do this kind of for loop, or what we can do is we can do list comprehension. So what we can do is instead of doing this 3 line of code, so instead of doing this 3 line of code, we can convert this 3 line of code into just this single line of code. So we can write squares as just this 2 square brackets, x times 2 for x in nums for each. So this is also the same thing, but we are bringing this for loop within this list as well. So we can, for list we can do this. So this helps us to shorter our code and make it more readable. Okay, so for list, so this is very useful, this list comprehension, right? So this 3 line of code was just changed into this x square for x in nums. Alright, now let's come to dictionaries. Alright, sorry. Okay, now for we come to dictionary. So what dictionary does is it stores a key and a value pair. For example, let's say we have this dictionary D, which has now dictionary is divided by this curly brackets. So this was defined by the square brackets. So here what we have in dictionary is that we have a key. Let's say we have the string cat, and then after this colon we will have the variable or the we can say which is called a value. We can basically we have the value variable which will be paired with this key. Okay, so for example we print t. If I just print t and square bracket, if I print, instead of giving index I will give this key value which is cat, then I will get the value which is assigned to this cat, which is cute and meow. So which is a list cute and meow, and I will get list cute and meow. Then this key value could also be a number as well. Okay, so you can have this number as well, one of the key, and it is like the value is some gibberish word. Okay, that's fine. Alright, then okay, now then we know that this value for which we have this key cat, it is a list. So we can even call, so this will act as a list, and we know that for a list we can call this we can, using the index of the element, we can call that element as well. So if I do this d cat square bracket cat, and then this square bracket this 1, then it will go to 0 and 1. Here we have list 0, 1. Alright, we have here 0 and 1. So it will go to this list and go to the index 1 and will print meow. Alright, then we can also check for a key in a dictionary. So if I print cat in D, then it will check for the key cat in this dictionary D, and if it is there or not, and since it is there, so this value will print true. So this will be a true. So the value that is printing is true. So it will be a Boolean variable basically. Okay, I can even store it in some variable as well. So for example, new, you say cat in D. Alright, so I store whatever is written by this cat, finding cat in D, and this gives us a value true, which is a Boolean variable. Okay, and you can say that you can check zebra, and zebra will be, there is no zebra key in this, so it will give a false. You can also check, like let's say you think that okay, the cute is in this here, so can I find cute in here? But actually it will give you a false value. You can see that if I even do a variable this, okay, then this value will be a false value. Okay, so it only search within the key values only, whichever keys we have. So it only search if that, it's considered that if I do this whatever something in D, then it will search for this in the key values. Okay, so like is this like whatever string or number, is it one of the is it one of the keys or not in the dictionary? Okay, then what we can do is, okay, so like we can even add a new dictionary. You can set in a new entry in the dictionary. So let's say I set this D fish equals to some vet, okay, string. So now my dictionary has changed. Alright, I can print this D fish will be vet, and my dictionary has now changed, and it has at the end it has this key fish, and the value assigned to that key is vet. So I can even add new key and value to my dictionary. You can also okay, this you can also leave it empty as well. So if I do an empty thing, then it will be just an empty string there. You can't leave these completely empty. You have to give some value, otherwise this gives an error. That's an syntax. Okay, syntax. All right, and D is a dictionary type. Okay, then let's go to sets. So now sets are basically our unordered collection of distinct elements. Alright, so these are unordered. For example, okay, so again for sets also we use this curly brackets, but we don't provide any key and values here. So it has two elements, cat and dog. If I print animals, I print this set, then it will give me value cat and dog. Alright, and the length of this, if I print the length of this, then this will be 2. Alright, it is 2 here. Alright, now I can add an element also to this set. I can do animals.add cow. Okay, so what if I print animals? So you can see that this is unordered. Okay, so sometimes so this is now adding it to the end, to the start of this. So this is getting added at the start of this cow. So initially if you were appending, it was going okay, so animals.add cow will change this set to cow, cat, dog, and this is unordered, so this cow can go anywhere. Right now this is going in the start only, but it is different from that append. Then if I find this type of this animal, then this is set. I can ask now if I try to add something, an element which is already in the set, then it does nothing. Okay, I did it and I printed the animals again, and it's the same set. Then we can again try to find if this cat is in animals, we can try to find this element is in there, and that is true here in this case. Now since these are unordered, I could not assign, okay, I could not find, like if I try to find some similar to some dictionary or something, some list or something, like you think that okay, this is kind of a list, but it's not. Okay, this will give an error. Like list, you can do this if it was a list. Basically as it is written as set object, is not subscriptable. So this thing which was so it seems like a similar list, but it is unordered, and you can't do the same thing as you can do in a list. Then let's come to tuple. Okay, a tuple is an ordered list of, okay, now a tuple is an ordered list of values. A tuple is in many ways similar to a list. Okay, but one of the most important difference is that tuples can be used as keys in dictionaries and as elements of sets, while lists cannot. Okay, so that's the difference between list and tuples. So tuples can be used as keys in dictionaries and they can be used as elements of sets as well. Okay, but they could not be, but while list cannot be, you cannot use list as elements of sets. Okay, so you can check it out. I am not providing examples for this, but I will just provide for the dictionary. I will not provide for the sets. And the tuples are also used to store constants in a code as they are immutable. So tuples are immutable, so they can also be used to use this thing, these values as well, because you cannot change the tuple. So you can create a tuple which has some constant, and then you can just use it because you know that those values are not going to change. Okay, for example, let's say we have a dictionary. And tuples could be also, basically tuples are more interesting because like you can define a set of constants and the tuples could not be changed. Okay, they will remain the same. You cannot append it, you cannot include new value to it, although you can change the, if you assign variable to something else, that variable name to something else, then the things will change. But basically if you have that variable number, then you cannot basically change those constants. Okay, so that variable remains, it is not mutable, just like a list. So it's not, that is also a difference between tuple and a list. And that's why most like it could be used in list. For example, now let's say we define a list dictionary here where d is equals to x comma x plus 1 colon x for, okay, this is the concatenation as we have written. So we can write dictionary also in similar this way. So this, we have done this for the list as well, if you remember this list comprehension. So this similar kind of thing we can do here for our dictionary as well. We have to write dictionary, so we can write for x comma x plus 1, this is our key value, and our value for each of this key is x for x in range 10. Okay, and this is how you define a tuple. And if I find this dictionary, so the dictionary will be from 0 to 0, 1 will have a value 0, 1, 2 will have a value 1, and so on up to the tuple 9, 10 will have a value 9. Sorry about that. Okay. Okay. So like here you can see that we have defined this dictionary, and we have used this tuples as a. I guess we have got tuples or tuples. Maybe I'm pronouncing it wrong, but you can check. But let us hear it for now. All right, and you can check that, okay, these are tuples. Okay, they are defined by this 0, 1, and again for the dictionary, this is the dictionary, and again for dictionary I can use this key, this tuple 0, 1, and I will get this value 0. Sorry about that. Okay, yeah, we have the name. Alright, so we were here. Yeah, I guess one minute, I was just getting confused. These are it is pronounced tuples. Okay, I guess I was pronouncing it wrong. So it's a tuple. I was calling it tuple, but it is a tuple. As I remember now, I guess it is tuple. Yeah, so for basically this tuple are immutable and they could be used as keys for dictionary, as we have seen here. Right. So with the d and this key value tuple 0, 1, we will get the value 5. Okay, 0, correspond to 0, we will get the value 0. And let's say we define a new tuple t is equals to 5, 6. Okay, and okay, so this is our tuple 5, 6. Print t. We can see that this is our tuple 5,6, and if I do a dictionary and I use this key 5,6, I know corresponding to this key there is something, and that is 5. Alright, you can see in dictionary corresponding to this key we have a value 5, so it prints a value 5 here corresponding to that key. And then I can call this value t0. Okay, I can call, okay, so this is a tuple, and I can call this 0th index element of this tuple t0, which is 5, and we will get the value 5. So I can use these values, but since tuples are immutable, so if I try to like assign something to this something, so I want to basically try to change, as I changed this element of list, so that is not possible, and because it is a tuple for tuple object does not support item assignment. Okay, so that is why these tuples are immutable. You cannot do an item assignment on these tuples. Alright, we can't change these tuples. Okay, then alright, so that's why these tuples could be used for constant in scripts. Now for example, let's say I have to store some constant, let's say for the value pi. Okay, for just to show you how to define a tuple with just one element, I'm going to use just one constant, like only one global constant we are trying to keep. So let's say that's the value of pi. Now I type the value of pi is this type. Okay, just change to 0. Alright, and let's do this. Alright, and then value of pi is this, and okay. Now now if I had stored this value in a list, if I have like more, I could have more than one constant, but let's say for example right now I'm just taking one constant and I've stored it in some list of my constants for the program, which is defined by pi 0. So I will just use it pi 0, which is a you can see this element, this is a float value, and the value of pi is this. Since this we know that lists are immutable, then I can just change this pi 0 value to some 1000, and now my value of pi, which is stored in this pi list, that has been changed. So this is, you don't want this to happen in your code. So what you can do is you can store these constants in a tuple, and what will happen is okay, so now if you try to assign some value, as we have seen here, you cannot assign a value to this tuple, and so object does not support item assignment, tuple object, and thus we can't change the value of pi basically here. And to define a tuple, now remember that this class will be float. Okay, now to define an element here, okay, so here this gives an error, but remember that to define an tuple with only one element, you have to define it like this. You have to use this brackets and curved brackets, round brackets, and then you have to use a comma at the end. If I don't use this comma, then what happens is that the Python doesn't know that I have created a tuple, because it doesn't, it has this bracket, but it just has this one element only. So if I does that, then type of pi 0, it gives error. For Python, this pi is now a float. It's not a tuple now. Alright, so define a tuple, you have to define this comma. Alright, you have to use this comma, and then you can, and then you will get an error because you can't assign a value. You can't change this tuple, and thus your constants remains safe in here. Alright, so basically instead of storing your global constant for the program in a list, it's better to store them in a tuple. Here I just made a tuple with just one single element. You can have a tuple with many constants, like gravitational constant or Planck's constant or something. So those values will not change, and you can even call out to them similar to how you call out for elements in a list. It's just that they will not be changed in the code. Alright. Now let's go to the function in Python, and also let's if else if condition statement. So as I have mentioned earlier, this def keyword that is used to define a function in Python. Alright, they are quite behind. Alright, that is used to define a function in Python. So what this function is using, so this is how you define a function. You give a function name and then you give whatever the inputs you are providing to it. So let's say you are giving a variable name, and also you are giving another variable, and you have to assign some value to whatever the second variable attribute that you are giving. So you can give this variable, or they are called attributes. Sorry. You can have this like name. So I have this two variable, name and route, and these are my two attributes. And here I have already assigned a value to false. So what it helps me is that if I call out this function and I don't provide any second attribute to this function, so that will not be a problem because this value has already been assigned. So, but if I give some attribute here, then it will assign that value to this variable. So now then in this function we are doing an if-else statement. So what we are doing is we are doing so what you can do a function, you can do something, and you can return some value or values as well. So like we have seen for the range function. So range function returns you a list of this integers. So if you can also make a function, and that will also return from that also you can get some return of something. Okay, and in this function we have written an if, else, elif and else condition statements. So what it does is that basically it checks for, like, after if there will be some statement, and it's checked if that statement is true or not. Okay, if that statement is true, then it executes whatever is written in this indented part. It will execute whatever is here. Here this is just a print statement, and then it will ignore this elif and this else statements. Okay, whatever is written below them. Okay, and in case if is not true, then it will go to this second elif, which is basically else if that is not true, then check if this is true. Okay, and if this is true, then it will execute whatever the statements are provided here after this indentation, and then it will ignore this whatever is else, whatever it will ignore this else statement and whatever is written here as well. Okay, and similarly, if both if and elifs are true, then else statement, whatever is written in else, that will be executed. So this is the condition statement, if else statement. Alright, and here with function, so within the function you can do whatever you want to do, and then you can also return a value. So here I am returning the value name as well. So what I am doing, so here I am calling out this function with this one single attribute, Bob, this Bob string, and I am on whatever the value this function is returning, I am storing in this variable ans1. Alright, and then similarly I the same. Okay, so what happens here is that, and then I print this ans1 answer ans1 underscore 1. So what it is doing, okay, so I have given a string Bob. So what it will go to this function, it will assign this variable name to this string Bob, and since I have not given any second attribute, it will assign this route variable to false value only. Then we go here, we see that, okay, this first we go to this first if statement. We see that, okay, this name has a string and it is not equals to Akshay, so that is true. And but route variable has a false, so by AND logical this will be false, so this is not a true. So since this if conditional statement is not true, we will go to the elif statement. So basically it check if that statement after if and elif, that is true or false. That is what we are checking. Now for elif, it checks, okay, name is exactly equals to Akshay. It is not, then whatever is in the else, let's just do it. So it prints hello, and this is one of the way how you can dot format name, so you can go over more about it. So this is one of the way to basically if you want to print this some variable here. Alright, so it prints hello Bob. Okay, it prints it executes this else statement, and it also stores and print ans1. It also stores the value name within this ans1, and that name variable is Bob. Okay, or I can actually I can actually return both of them loud as well. Okay, I can execute I can return both of them, and what you will see in that case, this ans will become a list basically. If I print ans, so it will be a let me just do this. Right. It will be a tuple. Okay, so this is also important. So, or if I guess this is also possible, we can return a list as well. Okay, so what we are seeing is that if I just give you these two values, if I say okay name comma route, so you can return two values, then it will return this two, that is both Bob and the loud, since we have not defined anything, we have not given any attribute for that variable. So any value for that variable, there is no second attribute here. So and it has already assigned something, so that gives that is just false, whatever is stored there. But it will be a class of tuple. But I can also return a list as well here using this, and then in that case it will return a list. Alright, then you can give a second attribute route equals to true, and route equals to true in both ans2 and 3 in case. In ans2, what happens is that it will run this statement, first statement, if statement, and we will print this hello Fred, and the value we have a Fred and true, and which is a list. And then for the third statement, this elif statement is true, while this if statement is not true. It is not equals to this Akshay, and this it will print this hello to me as statement, hello to me, and then the value this Akshay and true list it is returning, which I have stored in ans3. Now if we change this if statement to just route, okay, so I'm just taking if route is true or false, and then the if statement will run. So for check see for this ans3, so what is happening is that now I'm getting this hello Akshay instead of this statement. So my input for the function is this Akshay, and this route equals to true. Alright, so that is exactly what this elif statement is. Alright, but this elif statement is not being run by this, otherwise it would have printed hello to me. Rather it is printing this if statement, because this if statement is right now true, because if statement now, instead of this checking the name, it is just working out with this route variable, and route we have seen that for this input the route is true. Alright, I have given for ans3, I have given route equals to 2 here. So that's why it is just going to this first if statement only, and since if statement is true, it is just executing this if statement. Although the else if statement is also true, it is not being executed. So just to show you this once, that in some cases maybe both if and else elif statement could be true, but whichever is but then if that if statement is true, then this elif statement will be neglected. Similar in case you can have multiple elif statement as well, and if you have a multiple elif statement, then in that case also whatever the first elif statement is, if that first elif statement is true, then the next elif statement will not be executed. So you can check this out on your own. You can do some more example, you can modify these functions further and check yourself. Then similarly, this is the same example. You can also just get a return, so that this function just takes two attributes, take your first name and second name, and if you give this two attributes, then it will just gives you, it will just, what it does is just put a first name, it is concatenation of the strings, and then you can it returns whatever the concatenated string is, which is given a variable name, full name, and and I'm storing that in my variable my name, and that is printing my name. Alright, now if you don't give this attribute, if you don't give, okay, the function wants a second attribute, if you don't give it, and you have not assigned any value there, then it will give you an error, which is given that full name missing one required positional argument, second name. Alright, so this second argument that is required. Alright, so I might be saying something wrong about maybe the attribute or argument something, so I'm actually not sure if this is called attribute something, but I guess it is quite clear. Basically you have to give some values for those two variables that the function is taking in as an input. Okay, if there is no something assigned already, if I assign something here, like I have assigned already to this variable, I have already assigned some value, let's say false, then even if I don't give it a value, that is okay, it will just take whatever the default value is. So that is how the things happen in Python functions as well. So for the parameters, there are already some default values, as we are seeing for the dot salt, so that also works as some function on that method as well. And since there were some parameters are already there, it will just use the default value. So this is basically the default value for this parameter, for this variable or parameter. Otherwise we have to, if the default value is not there, then we have to provide a value. Okay, then in the end, okay, this is the end of the basics, and we are quite late actually. This is already 1 hour 26 minutes. Sorry about that. Okay, yeah, so last part is this while loop case. So we can get into the issue of infinite loop for the while. For example, this is a very simple while loop, like you can have I equals to 0. Now for while I is less than 5, you have to print I, and I equals to I plus 1, and or I could have used plus equal, but let's just use here this. So it just print plus equals to 1. But if indentation is not proper, if I use, instead of this, if I use this, then what happens is that we get into an infinite loop. It will just keep printing 0 0 0, and it will be an infinite loop. I have to interrupt it now. Okay, so please take care of that, and so basically take care of this indentation as well. This indentation should be correct. So you think that, oh, I have put this changing of my variable within the while loop, but the indentation was not, maybe the indentation is not proper, so it will not, the Python will not consider it within the while loop. While okay, and also you might miss this statement within your while loop. So this is a very simple example, but this sometimes can happen, and you might get stuck in an infinite loop. So just check that you are updating your index for this while loop. And while loop also works in the same way. While this statement is true, this whatever is within this loop, it will be executed. Alright, let me just stop sharing. Right, let me just share again now. Let's just go to the NumPy tutorial. I don't think, okay, I guess this will just be a Python tutorial one mostly, because we are already out of time. It is already 1 hour 27 minutes. Right. Okay. Okay. So now this is a NumPy tutorial. So again, for further learning, you can go through that tutorial on this site as well. They have a NumPy and the SciPy as well. They have the tutorial. They might have something more. And there's what we can also go to the documentation, and there will be some examples. There are many tutorials you can go through. This tutorial will just help you out to just get started with all this stuff. Now we can use, okay, first we will import our NumPy, and we import NumPy as NP. You can now here within, instead of NP, you can use anything you want. You can even do like anything. Basically, you can use anything there, but then instead wherever you have to use NP, then you have to put that name. But it's better to use this one, so that other people who read your codes, because it is kind of convention, like you import NumPy as NP, but this as NP is not actually required. You can just import NumPy, and where you are using np.array, you can use numpy.array instead of np.array, but or you can use npi or whatever number you have, but it is better to import it like this, because it is being most of the people use it like this only. Alright, so let's just go to this. And NumPy is basically used for numerical stuff in Python. So let's say you have a list A equals to 1 2 3, then you can print type of A. This is a list, and you can make from this A, we can make an array, NumPy array, np.array, by using np.array of A, that will create a NumPy array if we print a type of A, alright. And then if we do an A of 1, if I go to index 1 now, 0 1, then we know similar to list we can do 0 1, and that will be value similar to list. I can change the value of A1. I can value A1 equals to 5. Then if I print A, let me just print A here. Okay, we have print A, we have value 1 2 3, and then we can change if I change with this at index 1, index method we have 2, we have changed it to value 5, so that this index that element value has been changed to 5. Okay, it is a NumPy array, and I can again create an array, and NumPy has many of these methods, like you can use np.ones. So I want np.ones, so that it creates an array of all ones, and I can also define the size 1 comma 2. Okay, so it will create an NumPy array of size 1 comma 2, so it will have just one row and 1 comma 1 only. You can use like 2 comma 2 only, so it creates a 2 cross 2, and we can call this, like if I call this B0, so it will be a list 1 1, and if I call out B0 0, so that will be 1. So basically NumPy could be used, and as you can understand, as you can see now, it could be used for this matrix stuff. Okay, if you only put a 2, then this will be just a simple list array, alright. Just to if you have it out, so you can check this out. So basically you can do some changes and you can see what these things are. Okay, it will create an array of ones, and these are float actually. You can also try to type of this B0 0. So it is creating a matrix of NumPy floats. So these are floats within the NumPy array. Alright, then np.full. So there is another method in np.full. So this will create NumPy. This will create basically in 2 comma 2 matrix, and we define the constant value 7. So it will create a matrix with constant value 7. So by this you can create this kind of constant array. np.I we create a identity matrix, and with this integer 2 or 3 we define this. So this will create a 2 plus 2 identity matrix. Here we can see this is the identity matrix. Then this np.random.random 2 comma 2, it will create an array filled with random numbers. Okay, so it will create an array of filled with random numbers from 0 to 1 only. So here you can see these are random values. If I run again, these values will change. This will remain between 0 and 1, and you can go to the documentation and see more about all of this. Alright, and okay, let's just go to this A equals to we are already quite late. It's 33 minutes. Okay, we have just 30 minutes, so we will just complete this fast, and I guess this tutorial session will only be a Python tutorial only. So let's just do this np.array. So what I'm doing, I'm making again a matrix kind of thing, and I'm taking all this kind of list. Okay, I'm taking 1 2 3 4, I'm taking 5 6 7 8, and I'm taking this 9 10 11 12 matrix. Then I will just let's do print A. So just run it once. So here you can see basically we have created a matrix with this first list as our first row, the second list is our second row, and this third list is our third row. And if I try to print A 0 comma 1, so okay, by this basically instead of doing that, if you remember, if I had you can do a 0 comma 1 as well, or if you can do this kind. Okay, either we can do this will also go to the 0th row. So 0th row, so indexing, we know that indexing starts from 0, so it will go to 0th row and the first column, so that will give us a value 2. Or you can do this, or you can use this 0, 1. So for NumPy array, you can actually just use simply what you will use in a linear algebra matrix. Okay, so 0th row and the first column. So it understands that NumPy array. So it will go to the 0th row and the first column will be this 2. Alright. Now here remember that you can't define it like this. This will create an error. Okay, if you try to define this, because this will not be a proper matrix. It is too many indices for array. Array is one dimensional but 2 were indexed. Alright, so it will give you some error. So you need to have this. You need to keep these things. Keep in mind those things. This is similar to a linear algebra. Things are similar. Then we can again use the slicing method. So what it is doing is that if I do this A, and for row I am saying there's a column 2. So it will start from 0 and 1. So in this B, what it will do, I will start with 0 and 1. So 0th row and 0 and first row. Okay, in row with index 0 and index 1, and the column with index 1, 2, 1 and 2. Column with so row with index 0 and 1, these 2 rows, and columns with index 1 and 2. So that will be 2, 3, 6, 7. Okay, this will be 2, 3, 6, 7, and if we print B, then that is what we are getting. We are getting this matrix 2, 3, 7. So from this big matrix, we have taken out this small subsection matrix 2, 3, 6 using this slicing method. Alright. Then again similarly we have this big matrix. Okay, print we have this A matrix. Then we created an NP array which is 0, 1, 2, 4. Then you can do an np.arange. Now arange also, if you, again we can use this help command. Arange. So help command tells you that it is an array of evenly spaced values. So what np.arange gives you, it gives you an array of evenly spaced values. Alright. And then you can actually go to the documentation and learn more about it. But just reminding you, like you can go and take help with this. So with np.arange, I have given 4. It will exclude, like most of the time as in slicing. It will and range function as well. It will exclude 4, and it will give me a list, an array, and NumPy array of 0, 1, 2, 3 up to from 0 to 3. Alright, and B is again our NumPy array 0 to 0, 1. Alright, and we have printed both of them here. Now what I am doing is I am trying to print this for this big matrix A. A is our this matrix, this big matrix. I am printing A, this np.arange 4, comma B. Alright. So basically, so what will happen is for this, this index, this we know that print for A, np.arange 4, so comma B. So what will it will do is, it will take each of these elements of this np.arange 4, which we know is 0, 1, 2, 3, and for that and then so that will be that will be our row index. So let's say our row index will be 0, and our column index will be this element of B, which is 0. So 0th row and 0th column will be value 1. So we will print the value. We will have this in our this list A with this kind of slicing. This is also kind of a slicing of this A matrix. We will get the value 1. Then similarly for row index 1 and column index 2, row index 1, column index 2, the value will be 5. Column index 2, 0, 1, 2, the value will be 6. Then we will have value 6. And similarly at the end we will have row index 3 and column index 1, 0, 1, 2, 3, row index 3, column index 0, 1, we will have the value 1. So by this is also a way of slicing this matrix, this NumPy array, which is a form of a matrix here. Okay, so basically using NumPy array we can make this matrix, and we can do the slicing as well. Okay, now let's go back. Okay, so then again, now in this example again we have again created this NumPy array, which is matrix, and now what we are doing is we are storing, we are doing this bool iod underscore idx, and we are creating this a greater than 2. So what this will do is it will find all the elements of a that are bigger than 2, and this returns and this will return a NumPy array of booleans of the same shape as a. So, okay, so this will return a NumPy array of the same shape as a, where each slot of bool underscore idx tells whether that element of a is greater than 2. Okay, so what we can see that we have the similar NumPy array of Boolean values, and we can see that since 1 is not greater than 2, we have a false value here, and 2 is not greater than 2, so we have a false here, while 3, 4, 5, 6 they are all greater than 2, we have 2 values. So it has created a similar same size NumPy array, but this will be Booleans, and the value of the Boolean will depend on whether that element value is greater than 2 or not. Okay, so that is also quite useful. Then for data types for NumPy, then NumPy tries to guess a data type when you create an array, but functions that construct arrays usually also include an optional argument to explicitly specify the data types. Okay, so when we create an array, so NumPy tries to identify these data types. So let's say I do np.array of this list, then it try to identify the data type, and it thinks that okay, from here it identify that this NumPy array will have the data type int. Then similarly for y, if I make an NumPy array with this float, then it will try to identify that this data type by itself, and we can also define the data type by this np.int, but it is force a particular data type on it. Okay, and here you can see that if I run it, okay, the x dot for data type you have to write x dot d type here instead of type that thing, because that will give you type, that thing will just give you NumPy, but to find data type within this NumPy array you have to use x dot d type. Here you can see for x it has identified this integer as a float, and z it would have identified as int, but we have forced it. Let's say now we have a w as well, and I am taking a NumPy array which has this these 3 values. First of all, I'll just show you that so here what you can see is that okay, first of all we can define, okay, as we can define an array like this. Let me see if the data type here w.d type. Yeah, I'm not sure what this is going to be. Okay, this is something okay, so I can define an array which has similar to list, like we can have a list. So as we can define a list which has different kind of data type elements with different data types. Similarly, we can convert that array to a list, convert that list to an NumPy array, and the data type will not be defined. It will give you some this value. We can go for it. I'm not sure. But basically, what I want to show is that in this we can we can actually force a data type on it, but for this, if the elements they have if we have elements of different data type, you can't force the data type on it. Alright, so it will give you that you can't force it, you can't say that this is it. This will give you an error. Alright, so you can again try out yourself something different stuff. And alright, so this is the about data type. Let's come to array max. Okay, mathematics with these arrays. So let's say I have a NumPy array. Okay, I have written some data type float. I guess I have. Okay, so okay, yeah. So this is the what happens if you force a data type. So let's say I made an array and I just made it with an integers. So for integers, you can know that you can change integers to floats and floats to integers. Uh, you can change mostly change it to float to integer. You can change float to integer if it could be to the nearest integer. What you can do is for this integer you can use this d type equals to np.float, so it will force it to become a float. So this data type will now be a float, so and that could be done, but you can't change the string to that float data type. Alright. Similarly, we can have this np.array 5,6 and we can do this np.float. Alright, so now we have this numbers elements of float. Then these are the mathematical operations which are within NumPy. So I can do an np.add. So what np.add will do it will do element wise addition of this, just like a matrix addition. So like just like you will have matrix adding. So let me just print this x and this y as well. Alright. Okay, so I have an array x which is 1, 2, 3, 4, and I have an array y which is 5, 7, 8. If I do an np.add, x comma y, so it will just do an element wise addition. 5 plus 1 equals to 6, 6 plus 2 will be 8, 7 plus 3 will be 10, and 8 plus 2 will be 12. So that is the element wise addition, and it will give you this NumPy array. Alright, and if I do an np.subtract, then it is going similar to np.add. It will do an element wise subtraction. Maybe so if I do an np.add, then it does an element wise addition, as you can see. Now similarly, if you do an np.subtract, then if you do an element wise subtraction, it will be 1. I have given np.subtract a and b is for the second. So 1 minus 5 will be minus 4, 2 minus, similarly 2 minus 6 will be minus 4, and so on, or minus 4, right? And then we can do an np.multiply. Again, it will do a element wise multiplication. So 5 times 1 will be 5, 6 times 2 12, 7 times 3 21, and 8 times 4 32. Then we can also do an element wise division with np.divide. So by using np.divide a comma b, as is shown here, np.divide x comma y. So it's x comma y. So it will do an this is x and this is y. So this is x, this is y, and we do an np.divide x comma y. So that we just divide element wise division. 1 by 5 will be 0.2, 2 by 6 will be this 0.333 or something, and so on. Right? Right. 4 by 8 will be 0.5. Right? Then np.sqrt of x. Okay. So now we have done np.sqrt of x. So dot that will give us square of each element by square. So 1 square is 1, square root element by square root. So 1 square root is 1. 2 will be square root will be 1.414 and something. 4 will be 2. Okay, so that is the same. Then we can do a dot product. Now we can do a dot product as well. NP dot is x dot y. So we are doing a dot product of x and y. And remember that for dot product, again similar to the matrix method, you have to go with the same. But what x dot, what this will give us? So this thing, we have a matrix. We have a 2 cross 2 matrix, and this will also similar to in linear algebra 2 cross 2 matrix. So it will do a dot product. What you will get in linear, if you do by your hand or something, if you do by on a pen and paper, then you will get the similar 2 cross 2 matrix. And then you will, so by the dot product you will get NP dot array, which is like this 2 cross 2 matrix, which will be the dot product of these two if we consider them as a matrix. You can check, for example, first row into first column, I guess like 5, so 14, 19. So this element, yeah. So you can by this you can do the dot product. So as you can see, for linear algebra, doing linear algebra in Python, NumPy library is very useful. Let's go to some function, and okay, we are quite ahead of our time. It's now 15 minutes. So let's say we have created this NumPy array x, np.sum. Now what np.sum? So there is np.sum method. It computes sum of all elements. So if it's a sum of all elements, it prints 10 here. Then np.sum, if I do x and x is 0, what it does is it computes sum of each column. Okay, so if it is x, again we are giving some extra parameter value. On default it calculates sum of all elements. If I do x is equal to 0, it calculates the sum of, it will give me an np, it is array, and you can do a type as well for this if you want. Just do a type. Alright, yeah, so it will give you a NumPy array, as you can see here. This will give you a NumPy array. Okay, so after it computes sum of each column, so it is the first column is 1 and 3, so 3 plus 1 4, 4 5 6. Alright, similarly np.sum, if I do x is equals to 1, it will compute sum of each row. So 1 plus 2 is 3, and 3 4 5 7. So it will give you a NumPy array with the sum of each row. Then again we can even reshape our NumPy array. For example, we have, let's say we have a v NumPy array which is 1 2 3. Alright, so I have this in form of a row only. I can print this 1 2 3. If I do a reshape and I provide this parameter 3 1, so what it will do, it will give me basically a kind of this NumPy array which has this 3 rows and this 1 column. Alright, so it will reshape it into this form. Right. So basically, you can convert a row into a row into a column vector, row vector into a column vector. Similarly, okay, you can do this reshaping here. Okay, now let's. So now we are in the last part of this NumPy tutorial, which is the complex numbers in Python. So complex numbers are you don't require NumPy library to define complex number. They are similar to integer, floats. They are also defined in Python. But NumPy has something called np.conjugate, which helps to find the conjugate of those complex numbers. So I've included that complex number part in here. So let's say we have a variable a, we have a variable b with 0.8. So how we can define a complex number in Python? We can write a plus b. It is the multiply by 1j. So that will gives you a complex number. So the c will now be a complex number. And let me just type. I have printed a type of C. Type of C. Let me just put type of C here. Alright. So this will give me a complex number 1.5 plus 0.j, and it is the type complex. So this is a complex number. So in Python, complex number can also be defined. Or so you can either define like this. You can take two just integers or floats or whatever, and you can just multiply whatever is your imaginary part of your complex number. You can multiply it by 1j, and that will become your complex number. Or you can use this complex function, and you can write a comma b, and that also will create the same complex number. Here you can see. And using NumPy has this. This method, like you have you can use np.conjugate, np.conj. So what this will do is it will create a conjugate of your complex number. Okay, here we can see it is 1.5 minus 0.8 G. So we can do this numerics as well. Then we can also take out the real and the imaginary part of this complex. So our complex number 1.5 plus 0.8 G. We can take out the real part and the imaginary part from this, which is 1.5 and 0.8. Using this again, using the NumPy library. That is the usefulness of NumPy library for complex numbers algebra. Then for complex number, you can do this addition as done. So like C1, let's say your C1 complex number is 1.3 minus 0.3 J, and okay, you can define it like this as well. Okay, yeah, you don't have to. You can do this with a simple J only. You don't have to multiply it by 1J. By 1J basically, why I put a 1J, I will show you later. If you have to. Okay, yeah, 1J, or you can just write G. Yeah, I guess I got confused. You can do it. Okay, you can do it like this. Okay, you can write it 0.3 times 0.3 J as well. So that it understands this, or you can do this multiply 1J as well. So whichever suits you. So it will just say that okay, this is J times 0.3. That will be 0.3 J. Okay, so 0.3 is 0.5 J. You can write this as well. Right. So similarly to this, okay, so you can write in simple way as J is basically defines your imaginary part in the complex number. So you can do if you have this C1, C2, C3, so you can see that these are your two complex numbers, and if I do C equals to C1 plus C3, so it will just add this first real part. This is a real number, so 1.3 plus 5 will be 6.3, and imaginary will not change. I can use a C1 plus C2 as well, which is just these two complex number adding. So the real parts will add, we will get a 1.6, and then the imaginary parts will add, we will get a 0.2 G. Alright. Then similarly we can do a multiplication as well, and as you know, multiplication of complex number, it just does it in the same way. So the real parts will multiply 1 times 2.3 with multiplication. Okay, so multiplication will happen similar to what happens in a complex number. So it will be 1 times 2.8 and 1 time, and there will be some real number from minus 0.5 and 0.7, because of which we will get this value. So we can do this multiplication of complex numbers as well. Then why I wanted to show you this is, okay, you can just put J as you can't define it by J. So why you need this 1J is but if you want to define some this iota, you can define it like 1 times into 1J. You can't do this J as well, you have to do this 1J, or I should have done this as well. You can write it as 0 plus J. Alright, so iota, this will be used in our one of our tutorial as well. So since V function could have complex numbers, so that's why for quantum mechanics, knowing how quantum complex numbers are being used in Python, that is also quite useful. So we can define our iota, and if I do an if I print iota this way, and I can if you do an iota square, then we know that iota square has to be -1. So here we can see that, but remember that the type of this iota square will be a complex right now, because it will not change the type of this, and we can have the real part is like -1 and the imaginary part is 0, and you can define this iota like this as well, like 0 plus j, as we have seen here. Indentation, remember the indentation should be proper in Python. One minute, I guess. Yeah, sorry about that. Okay, yeah, you have to write 0 plus 1j. Alright, so you can define iota like this, or you can define it like this. In both cases it will be 1j. So we are done with our NumPy tutorial as well, and we have almost completed our 2 hours actually. So let me just stop sharing screen. Right. Okay, let us go to our last Python tutorial, which is on matplotlib. This is a short one. Alright, let me just disconnect. Okay, so let's come to this matplotlib library. So here, this is a very small tutorial, and there is some playlist also on YouTube which have much better example for matplotlib, and you can again the that link as well that I've shared in the previous basics tutorial and the NumPy tutorial. There are examples for matplotlib that you can check out. So again, first we will import these libraries matplotlib.pyplot splt and import numpy sp. Then this cell I have just defined some lists which we are going to use for our plotting. So first we will do the line plots, which will be used most often. So for plt.plot, so I have taken both this list, okay, and I've used okay. You can use this extra attribute, like you can define the color, the marker size, the marker, and you can define the labels here. And then for this, I'm creating a line. Line style is case. Line width I have defined as 2, and labeling I have given. This is the plt.title is median cell age and median salary USD, and this is used to define the regent. plt.grid is for the grid, if you want the grid or not in your plot. Tight layout you can Google. This is mostly for the spacing part only, and is mostly I guess useful if you are saving it. You can also save your plot using plt.savefig, and plt.show shows your plot. And remember that default plot here we have not defined that this is a line plot, because default plot is a line plot. And here we have got our line plot. So our blue color one, we have given it a marker dot number, and so it is stating this marker dot line plot, and black one is our this lines, and here is our region. The labels we have already given in our plt.plot itself. Now so either we can do this, or if you don't want to give too much, if you don't give all these details, then you can I can just simply plot this as well, py_dev and whatever this variables are, and instead of and I can give my labels in my this region using this, right? Within the PLT region I can give my labels, and if you plot it, it will plot just 2 lines, but then there is no, it will just select some different colors randomly, and 2 different colors, and then the labeling will be that we have provided already in the legend. Or in the same case, like you can go with something random colors and everything, but you want the legends to be defined within the plt.plot. Okay, I have okay. So yeah, so that doesn't matter. I have given already in legend, but I can actually comment it. I can comment it out, and I can have this plot. Alright. Then we can have several kind of plots, and like for example we can have a bar chart as well. So for creating a bar chart, you have to define some width for your bars, and you can have use plt.bar, and then these are the same some x and y variables, and in width you define your width, and then label define these labels, and I'm plotting the median salary USD and age on the x label, and plt.title x label y label, they are just for the x labeling and y labeling and the title. Then I will just plt.region and show, and from here you can see this bar chart. So that is the same plot that I've shown here, which has x is age and y was median salary as a line plot, and again we have x as age and y as median salary, but now we are plotting the same thing as a bar plot for each of this age value, what is the median salary for Python developers and the Java developers. So that is the data that we have, and here it was as a line plot, but you can also give it a bar chart as well. Similarly, we can do an histogram as well in Python. So let's say we do a normal distribution which has a mean value at 170, has a standard deviation of 10, and we are giving like 250 values. Alright. Okay, it's 250 values. So you can see that for this distribution X, the minimum value is like 142, maximum 201. We have 250 of these values, and then we create the bins. This basically is the region that defines the regions from where we get the histograms. I have like 140, 150, 160, 170 up to 200, because we know that minimum and maximum values are ranging from this 140 to 200. So our bins I have taken with a separation of 10. Then you use plt.hist, you put your x value, you put your beans equals to, in here we have the list is bins, is named bins only, and then the h color, this is some extra parameter you can add. Then this is here we are, and you can also use this hex values as well, instead of using some variable name b or something for the color. If you don't remember that, like to represent, let's say to represent some particular kind of color, you don't know what is the, or is there is no very letter is provided like b, k or something, then you can use this hexadecimal value as well of that color. I guess you can use hex values for color palette. Alright, so that is what we are using here for the histogram. And then histogram, and then you can this is, you can Google, I am also not sure right now, but basically this creates a line within the plot, which is at x value median x, with color we have provided, and label, so we are also labeling it, and we are providing this line width to be 2. So it just plot a line along the y-axis and given a particular x value. So we are using it to define our median value for our distribution. Alright, and these are the x label and y label. So from here we can see the frequency, and it seems it's, as you see, it's look like a normal distribution. Alright, and from whatever the values are, from 140 to 150 is our bins values, 140 to 150, 150 to 160, and so on up to 190 to 200. Alright, and let's just go to our last plot, it's the scatter plot. There are other kind of plots also, like the pie chart, so you can make, but I'm not covering it in this section. So for scatter plot, let's say we have this x list, and then we have this y list. Alright, and for plt.scatter, so I have this x and I have this y. This s is the size of your marker. This is 50. Marker I am using this O, and h color, this is h color, and this is the line width, okay, which is 1. Okay, and here we are using, so this is the PLT grid. So if you have provided PLT grid, then equals to true, then this will create this kind of XY grid in your plot. It was already done, so you have these plots. So you can make this kind of scatter plot as well. Okay, and the line width is basically the h color width, is the h width. Like if I make a tan or something, so you can see the difference. This becomes like, okay, very large. And just give it 1. Okay, and I have put already the markers has to be 50. So like this, we can plot this scatter plot as well. Right, and you can go through this YouTube playlist or some other playlist as well, whichever you like, and to do this. Okay, so let me just stop sharing. Okay, so yeah, so we are already quite late. It is like more than 2 hours again. So in this tutorial we have done this basically turns out to be a tutorial only on Python programming. So we have learned about some basics of Python, and like different kind of data types, how you define a variable name, and then again like different data types like strings, integers, floats, booleans, the arithmetics, and a lot of stuff that we can do with strings. Then we also learned about functions. We also learned how to define loops, while loop and for loop, and the conditional statement as well. So hopefully that basic Python tutorial that helps you to get started with Python if you are quite new to Python. Then we also had a small introduction to the NumPy library and the matplotlib library as well, which are being used in this course. And so So that also gives you a quite good introduction, and I guess from solving those things also you can understand how useful those libraries are. Alright, this is the end of the session, and we were not able to get into the quantum mechanics part, so most likely I will include those I will try to include those things if possible within the regular problem solving sessions. Right, thank you.